All right, let's get started. All right, welcome guys to today's lecture on uh, higher order functions. Before we dive into that, we'll go over the problems that some of you guys have selected. Hopefully, it helps out. Please feel free to ask any questions if you guys have. So, for clone machine, we know that we're going to get an object that looks like this. That's the contract that we have, that we're guaranteed. So we just need to focus on an object that is shaped like Dolly. And so we need to return the clone, a clone version of this. And so how we would do this is we'd probably just, the name should be of his parent, but concatenated with the word clone. And then the clone machine should also push the name of the clone to the parent's offspring array. So what we'd probably want to do in this case is the following. So we have our function clone machine that takes in a parent that it needs to clone, and it will return a new object, right? And what we can just say is that the name is parent.name plus clone, and the species would be parent.species. And we can just take it exactly because this is a primitive value. If this was, the problem with this is we can't do the same for offspring because now this is the same array as the parents array. So they're not a copy anymore. They're actually pointing at the same reference. So we need to do a slice to make a copy. And then what we can do first is actually, because we need to also push the name of the clone to the parent's offspring array, I want to just say this is my clone. And then I could just do parent.offspring.push clone.name. And then I would just return my clone. The important thing to note in this case is that, number one, we could just copy exactly the parent's primitive values because those are copied automatically. It's not, if I change clone.name, the parent's clone.name isn't going to change because when we just pull the value, it just makes a copy automatically, and it copies the value and it puts it over into a new variable name. So when it's primitive values, we don't really have to think so hard. But once it's a complex value like offspring, which is an array, we have to slice it, because if we didn't slice it, then when we do this, we're also going to affect the offspring. So some of the tests should break because when we mutate the parent's array, we're also mutating the child's array because they're essentially pointing at the same thing. So once we do this, we're breaking the connection, and the parent offspring array is now completely different because we've copied it over into a new array that has, this slice will copy the values if it had any, but in this case, it'll just be a blank array. And then we return. don't think it likes that. Are there any questions about cloning? Important thing to note is just the distinction between primitive and complex values. Now we want to do slice, I believe. Splice. Yeah. This one is a little longer. So for this guy right here, we want to copy the splice method. And so I believe we need to think about two different things here. We need to think about an array that, let's move this to the side. We need to think about an array that we return, which is, we need to think about the original array, and also the array that we return, which is the array that has the removed elements, and then the original array, which is mutated because now we added apples to it. So I'm thinking just having two arrays. And this one I did take a look at the solution, so it's probably going to be pretty similar to the solutions that they gave out, but it basically is a good exercise in planning and, you know, trying to reason about with pseudocode before we actually start diving in. So I want to have an array where I keep all my values, an array where I'm removing those values, and then at the end we need to mutate the original array somehow, because we can't just have a new array. We need to actually change the existing array to point at, we need to actually mutate the existing array and also create a new one. So first, what I want to do is initialize my array of items to keep, and then I want to initialize array of items to remove, and this is what we're gonna return, which is a completely different array from the original one. And this original one, I can't return that because this is a whole entirely new different array that I'm creating. So I would need to somehow use this as a sort of marker in order to do some operation on the original array somehow. So like popping and pushing this one. But the reason why I'm initializing two different arrays is because if you start mutating this original array while you're iterating over it, that's pretty confusing. For example, if you're doing a for loop, and then while you're doing the for loop, you're adjusting the array, there's too much going on. So I would just keep things separate and not try and mutate an array while you're iterating through it. And then I would say from 0 to my first argument, which is 1, I'm adding all those add to array to keep, and then from first argument until first argument plus second argument, because this is the number of items to remove, so I need to go until the first argument plus the second argument, because that's how many we're gonna cut out, and add to array to remove, and then 2, 3, 4, 5, and then here I'll basically what else is there? Oh yeah, if there's any more remaining, so you know, we put this into the array to keep, We put this into the array to remove. And now whatever's after the array to remove until the end of the array, we need to keep that. So let me think here. We have, I think first we also need to add this last argument here. Splice is confusing. There's a lot of stuff going on. But I think after we add, we'll add, if there's an element here, we'll add that to the array. So, and then add the fourth argument. This is the second argument. So plus third argument. And then we'll add the fourth argument to the array to keep. And then we'll go from second plus third argument until the ends of the array, and add all of those to array to keep. And then now what's interesting is like I have two arrays. I have an array to keep, I have that array, and then I have a array to remove. So I have that array, and then I also have the original array, which I haven't touched yet. So OG array, right? I haven't touched that one yet. So I believe in the solution they go through this array and then they pop everything off of the original array, and then they add this array to keep back into the original array. And yeah, you actually would need to do that, because if you set this array to be this array, then you're changing the array. You're creating a new array. You're pointing it at a new array. That is this array to keep. So we don't want a new array, because this my array needs to change. When we call my splice on this array, we need to change the original array. And so we would essentially empty the original array and then push all these items back into the original array. And I know it seems like extra work. We could have probably done it all at once while going through the array, popping and doing all that, but I think that's too much going on at once. There's too much variation there, so I like to just keep things as straightforward as possible. So yeah, I guess now we just go through the array of items to keep. And push it into my array. And before that, we empty my array by popping all the elements from it. Seems like a lot to do, and that's because it is, and probably because this function is so complicated, I don't find myself using it frequently, but it's a good exercise to try and jot down what your approach might be. And just, again, I'm beating a dead horse, but it's really helpful to try and plan things out before you actually start coding it. But yeah, this is good exercise to help us review mutations and keeping the array the same, and understanding the difference between reassigning one array to be an entirely new different array that lives in an entirely different memory address versus mutating the existing array and having that existing array change. And in this case, we want to change the existing array. So I'd probably do something like create a function, mysplice, takes a original array that we need to mutate eventually, and it takes a start index and end index, or num to remove and item to add. So we just need to follow our directions now. now that we have our manual, this should be less difficult. So we just need to follow, step 1, initialize array of items to keep. So there it is. Initialize items to remove. Go from 0 to the first argument, which is the start index. Or this probably isn't the best name for it. Let's see. It's not the start index, but it's like the end of it's like however many we're gonna go from the start till how that index is how much elements we're gonna keep. So for let I is 0, I is less than array like this guy. I plus plus. So anybody have any guesses which array I need to push to in this case in my first loop? Any takers? In my first loop, I probably want to push to this because my instructions say, add to the array to keep. So I'll just do array to keep dot push og array I, right? And after this, I need to go from the second argument until second argument plus third argument and add to array to remove. So for let I equals, and then where should I start I in this case? If I ended here.
End index of items.
I'm just picking up where I left off.
Yeah.
And then I is less than, and then what should be my top constraint here? It's pretty tricky, but like how do I know when to stop? Like I'm here and I added that in. Now I'm going from here till how much do I go like to the right? Basically I can add, damn it, this to num to remove because I want to iterate however many times for however many elements I'm going to remove, because if I'm going to remove 3 elements, I need this loop to run 3 times. So that's why I add this number I add num to remove to end index in order to iterate and cycle through as many times as I need to remove elements. And then here I do array to remove dot push og array I, right? And then is this optional? That I don't know if this is always provided. Let me see. Yeah, so it might not even exist. This last argument right here might not even exist. So how can I check if it exists or not? Any guesses how I can check if this item is even passed in as a parameter? Well, basically I can just do if item to add, right? That means it exists. And so then I want to add it to array to keep. If it's not there, I don't want to push undefined, because if it's not provided, it would be undefined, and I don't want to push it. And then we just need to do another loop from I till, because I still am not guaranteed that I'm at the end of the array, but now I'll be at the end of the array. I'm just handling my right items now, the items to the right. And then I just do array to keep dot push og array I. And then here comes, I eventually need a return because it expects this call to return the items to remove. So I know I need to return array to remove. And that's fine because it's a totally new array, and we want a totally new array. We don't want this array and this array to be the same, but we also need to mutate this original array so that, when we console log my array, it is changed. And right now it won't be changed if we just stop here, because we did add to this new array, but the original array stayed the same. We never touched it. We never mutated it. So now we have to do something like, while og array dot length. I'm just gonna pop off all the items. So it's clean. Now the original array is just empty. And then here I'll push everything from the array to keep back into the original array. And does anybody notice anything weird about this? Like line 29, line 30. It'll never get to this code because I'm returning. So I'm gonna do this first before I return. See if this works. Whoa. I did look at the solution though. Because first of all, I don't even know, I never know what splice does, so I didn't really know. And then when I found out what it does, I was like, holy crap, there's so many different edge cases. And then if I was gonna present it to you guys, I wanted it to be polished and not just me scrambling for to handle all the edge cases. But I probably have never used this function because there's too much going on here for me. I just like using pop, push, keep things really simple, but in real life, you're probably gonna have to do something where you're keeping track of all these different things. And so it's not bad practice for that. But I would never dive into something like this and just straight up try to code it out. I would at least try to have some type of approach, even though it might not be a good approach, because I'm just thinking, my first draft, it might not be a good approach, but at least it's an approach, rather than, I'm gonna start writing a for loop and then try to, do another for loop, and then I don't even know what I'm doing. You're 10 minutes in. At that point, nobody knows what you're doing. So, yeah. All right. So if there's no other questions, then we'll go on to this lecture. And this is an important one too. This kind of is a foundation of all web applications, because web applications are for the most part event driven. If a website was a simple page with just text in it and you couldn't click, it was just like a book, for example, right? You can't even, there's no actions, then maybe we wouldn't need to learn about higher order functions. But because web apps today are very interactive and event driven. So you go onto a website and you click things, you scroll and like things start happening. You double click, you right click. There's all these different things you can do. You type into the form and then you press enter. Like there's so many events that we need to have this, we need to understand this concept of higher order functions. So it's like a fancy name, a function of a higher order. But really, it's not, I don't want to say it's simple, but what this means is basically functions are the same. You can treat functions the same as other values in JavaScript. So you can treat functions like they're strings or arrays or objects, meaning like you can pass a function into another function as a parameter. Usually we're used to, and I'll probably show some slides. I should probably be a little more visual. So functions, we think of them as special and they're its own thing, and they are special and they do have unique traits, but we can pass them into functions just like if they were a string. And when we pass a function into another function, we call that function that we passed in, we call it a callback. And why it's called a callback is because we're essentially giving a function to another function and saying that later it's going to be called back, I guess we can think of, but we're just giving it to the function to invoke it at a later time. Whenever it wants to call it, it can call it. So yeah, they're special. I mean, you can invoke them. Like, I'm not going to say they're like strings and numbers in identity, because you can do different things with them. They encapsulate code that can be reused at a later point, and you can invoke them, you can call them. But in terms of passing them around, you can pass them around like they're, a string or number. And we can also return a function from a function. So you could think of a function as some type of decorator that just creates a new function. So let's say, you passed a function into a function, that function could like return a function too. And we'll see the use cases for this. They may seem different, but they're just first class objects, which is another way of saying that they're very similar to other values in JavaScript. So let's think of an example here. So we know we can push strings or any values into an array. So when we do this, it should be happy, happy, happy. But we can also push functions in to arrays. It's perfectly legal. Now, the part that is kind of confusing is like you're not pushing in the function that after it's being called, you're pushing in the function and it hasn't been called yet. So in order to call it, you'd have to access the property on that array and then do the parentheses. So yeah, when we log it, they're just going to be function types instead of being a string type. And it's not the value of the return value of this function because we haven't called it. Meaning like it would be different to say, and this is something that is worth noting, is that let's say we had a function, add, and then it takes two values, just returns x plus y, right? And then let's say we had an array simple array or it's a special array. All arrays are special. And then we'll just, say for let I 0, I is less than 3 plus plus. We're gonna do special array dot push add. This, when we log the special array, it's just gonna have a bunch of functions that haven't been called yet. So they're just waiting to be called. It even gives you the name. This is a very special array because it's holding functions, but at the same time it's not a special array because functions are just like anything else. Now what if you wanted to store the value, the actual primitive value that this calls? Then we could do something like add one, like actually invoke it. And at this point, we're adding the actual sum, right? Because we're calling the function. But because we're passing it in like this, there's a huge difference because now I can decide when to call the function, And this is the whole premise of websites is when I click this button right here, when I click it, it does something, right? What it will do is it will run a function. Someone else wrote the code, and the code that actually runs when this is clicked, it's probably a lot of code. It runs your code in some sandboxed environment, and then prints out all the outputs, and it analyzes. It does, it throws errors. There's a lot of things encapsulated in that function. It's probably multiple functions, but let's just say it was one function that runs when I click this. I essentially passed that function in to an event listener, and only when the event happens do I want the function to be called. So that's the huge flexibility. I'm not calling it directly in my code right now. Like if I was doing this, then I'm calling that function right now. But if I pass it in, then I tell this array at some point later when you hear the event click, when someone clicks, run that function. Like don't run it now. And so you would pass that function, that run function, into this, right now we're passing it into an array, but in real life it would probably look something like run button dot on click, and this is a function, right? This is a run button is like an object, let's say, and then it has an on click property that's a function, and then here I wrote my function called run, and it's really complicated. It's a beautiful function, and it's but I don't want to call it right when the user gets to this page. Like I need it to just hang out and wait until the right scenario occurs such that it should be run. And so now I'm passing that run function into the on click, and now it's just the browser that's just waiting for these events to happen, right? And then when I actually click this, what it's going to do is it's going to run the function, but I'm not running it, if that makes sense. Like I'm never calling it explicitly. It's the background system that is all wired up with all these events and event listeners, and then that's gonna you give it your function you want it to run, and you say, hey, like when you hear this thing at a later point in time, run my function. And that's what gives websites power, because if we had to execute functions, like if we had to constantly execute functions, then the whole website we wouldn't be able to trigger things with our own actions. It would just be running, like it would just be like a slideshow or like a movie, like a clockwork, just all these things happening, and we're not able to interact with it. We're not able to control anything, but we are, because of the concept of higher order functions, that a function can be passed into another function just the same as a string could. And then you have the background process that's handling, when I click this, that the click event is emitted and it causes a cascade of events such that eventually this function is invoked. So yeah, I mean, these things are pretty it's kind of hard to see practical application, but that's basically it, is being able to have the flexibility to call a function at a later point in time. So we can have all these functions, and now when we access that function, we can call it. Because this function hasn't been called yet, we're just storing the bundle, but we haven't opened the present yet. We're just storing the present. We haven't opened it. We need to, if we want to open it, we have to invoke it. I kind of touched on this a little earlier, but we can pass functions into functions. So this function, well, does anybody want to take a stab at what this would log to the output? We've got a taker, got a brave soul. Function, yes. It will log function because I'm passing in a function and the type of a function is function. If I were to pass in a string, it would just say string, or if I pass in a number, it would say number, but I'm happening to pass in a function, and so it'll say function. So higher order functions, just to review, what are they? They're functions that return other functions, or they're functions that take a function as a parameter, as its argument. It could do both, or it could just do one of them, but that's what we mean when we say higher order function. It's quite a bit of delay in these. Okay, there it is. So yeah, at this point we're calling it, right? But we don't have to call it. We can. We probably should, if we're creating the higher order function, then we probably should call it, because otherwise why are we even passing it? Why are we even accepting it as a parameter if we're not going to call it? But when I mentioned the previous example here, usually when we create websites, we're not the ones that are defining this actual function, this onClick function. It's just there for us to use. So somebody else wrote it. So that's why we never specifically invoke this run function. But if we were the ones that designed the onClick handler, actually wrote this function's code, then yes, we would want to take in the parameter and eventually invoke the function. Otherwise, there's no point of accepting the function as a parameter if you're not going to call it. You can also pass it to another function if you're going to do that, but you've got to do something with it. So yeah, you can get fancy like this. Anybody want to take a stab at what this would log? We're passing in a function, say hi, which is, yeah, beautiful. It'd be hi Sadie, because it's kind of a bit of, you have to walk through a bit of a maze to figure out what's happening, but let's just break it down step by step. So we have says hi, and we know what this function looks like. This is what the function does if it were to be called. Now, when we pass it into line 13, we're not calling it yet, so it's not doing anything yet. So we pass that function into calls with name. So now let's see what calls with name does. It takes in a name, which is a string, and it takes in a callback, which is a function, and it calls the callback with the function, with the first parameter. And so it's essentially going to run says hi with name passed in, with Sadie passed in. There's a little bit of indirection here. It's things getting shuffled around. But what we can imagine is that callback, well, says hi basically just gets renamed as callback. So remember what I said? Let's just backtrack to yesterday's lecture where I did all those weird assignments in functions. So let's break this down a little bit. Just forget about says by for now. Just focus on the simple things. So what this actually does is it says let callback equals callback. That we haven't, it'll do this under the hood. And basically callback, right? When we actually pass a parameter, this becomes say hi. So we're essentially doing says hi. So we're essentially reassigning this function to be called callback, and then we're calling it. We're just changing the name, but it still does the same thing. We're just reassigning it to a different variable, and then we're calling it. So it's like we're saying let callback equals says hi, and then we're gonna call callback passing in the name, which is Sadie. So this is basically doing let name equals, Sadie, and let callback equals says hi. And then we're just playing with it. But again, parameter declarations do create the variables within the function body, not explicitly, but implicitly. So yeah, we're passing it in. It says hi gets renamed as callback, and then we call callback. It's an alias for says hi, and then we just call it. It's pretty cool because callback, because it allows the calls with name function to be so dynamic, because it could take in any function. And so now, as we can see, it's so flexible. I pass in says hi, it says hi Sadie. If I say says bye, it says bye Sadie. And I don't have to like rewrite the code. It's not hard coded. It just takes in anything and it just does the same thing with that. It's like a mindless machine that just takes in whatever you give it and calls it. So it allows you to be it gives this function flexibility. It's not just calls with says hi. It can call any function and give it the name property. The name parameter. Pressing onwards here. Let's try this guy. What is result? If I logged result, what would that log to the console? So you got to do a bit of following the path. Anybody want to take a stab? Yes, great work, Liz. It is hello world, because we're passing in the add world function, and that becomes func, and so we're essentially aliasing hello world to be func, and we're just calling add world with hello, and that should return hello world. So what is this doing right here? So what's powerful about higher order functions is that you can do the same thing to multiple times, meaning you could call the same function on every element in an array. And yeah, anybody want to take a stab at this? What this would print to the console? Basically, it would print yes. Great job, Anderson. So it would print hello Jane, hello Jill, hello Pip, hello Mike. Now this concept is kind of, if you guys have encountered map.filter, if you guys haven't, then you guys will, and this is a very commonly used method that exists on arrays. But let's just say we wanted to have, we had a bunch of names. Let's see what we want to do. Try to think of a example that makes sense here. Okay, so see, we had a bunch of names like Anderson, Liz, and Tifa, right? And we wanted to rename each student. We wanted to basically have a new array that also says, what, like student Anderson, student Liz, student Tifa. We wanted to add those to every single item in this array. And that's a pretty common thing that we would need to do. So in this case, it's a little contrived, but let's say, we had a bunch of items. We'll just keep it simple for now. So we want to go through and add student in front of each name. How would we do this? One way is we could just do a for loop, right? We could say we could create a new array. Right? And then we could do the for loop. But I'm already tired. Like, this is a lot of work for just something that I feel like it's going to be a common thing. Like right now it happens to be names, but what if they're, items, and we wanted to go through and discount all the items, like do a 20% markdown on every single item in the array. Like, I could create this for loop. It's not bad to do that way, but if you're trying to be really, if you're trying to write a little less code and maybe make your program a little less cluttered, then you might do something like names.map, and then you're gonna pass a function in here. So basically this map concept encompasses higher order functions, but it also encompasses like the concept of breaking a problem down into its smallest part. So let's say that we wanted to add student in front of each of these names. How about just not even thinking about the list? Let's just try to make a function that essentially just adds student, or appends string or something. And it takes the student, and then let's just do it one at a time. Let's just think about one item first. Before we try to bite off the entire list, let's just do one thing at a time. So if I had just a string called Anderson, how would I return student Anderson? I would probably do return student plus, given a name, plus name, right? And that's just the simplest case. And so what we could do now is we could say dot map, and then we could pass in this function and it'll just work. Like it'll take this function and it'll call that function on each element, passing the element into this parameter. It's higher order functions that work. This map is itself a function that takes another function as a parameter, and it'll use this function and call it on each item in this list, passing the element as the parameter. And so now when we say student names, it changed everyone's, it created a new array, and then it did that function on each element in this array. So it's higher order functions at work. Basically, if we wanted to break down what this map function looked like, it'd be something like, right? It takes a func, and then, you know, because it's a property of names, it'd be more accurate to say that it'd be like an object that has, you know, names as an array, you know, Anderson, Liz, and then it has a function called map. That's a function, and it takes in another function, and then it says return, it creates a new function, it creates a new array, and then it goes through each, you know, the actual map is something that'll go through each item in the list. So there's no way around for loops. Like, you will always have to, when you break things down, like these are just abstractions, when you break it down to its most basic level, it's just going to be a for loop. And then you essentially do new array dot push, and then you call this function passing in new array I as the parameter to that function, and then you just return new array. This is like how this map would be implemented, but it's kind of, if it's going a little too crazy right now, the main point is I'm passing in a string as a parameter, just like I would pass in a string or an object or an array, and then that string, that append string becomes func. Like I've renamed, I've essentially done let func equals append string, right? And then now I'm gonna call that function in some way, in some capacity within this other function. And that's pretty much how map works. And there's a bunch of these, like there's dot filter, dot reduce, you know, and there's just a lot, and a lot of it is a shortcut so that we don't have to do, we don't have to like write this out each time, and it's just a lot cleaner to see, and a lot less code. But it's also just higher order functions at work. Does the map function mutate? That's a beautiful question. Does it mutate the original array? That is a great question. Where's my? I can't. Sorry guys. All right. So map creates a copy. So map does not touch the original array. It's a great question. So when I do say student names and when I say names, they'll be different, because that's why map is so beautiful. It does not mutate, and that's why I use it all the time, because it's not changing the other array, and I don't want to change the other array, because what if somebody else depends on it? I don't want to mess things up for them, right? And so I just want to do my own thing. I'm not going to touch what anybody else did. So map I use like every single day. And this is my new array that map created. and this is the old array. It stays the same, exactly the same as somebody else that's using it. I'm not changing it for them, and I'm not gonna, affect their code, which may depend on the value, this array being this value. And so I essentially created a new array, and that's what map does. It returns an entirely new array. And if you take a look at the implementation of map, you would see that basically what map does is it creates a new array, and then it just does a for loop, and then it just pushes the function that's called as a parameter. It just pushes the function invoked into that actual array, and then it just pushes that value into the new array. So it looks fancy, but it's really just a for loop and instantiation of a brand new array. But that's a great question. Yeah, no, it doesn't mutate, and so that's why I use it, everywhere. So yeah, I mean, this is kind of the same idea. We were passing in a function, and we're calling that function in a for loop. This is how map is implemented under the hood. Is it takes in a function, runs through some type of array, and then calls that function on that element in the array. And the only difference here with map is that map actually creates a new array, passes this value into that array, and then returns it at the end of the for loop. So we kind of went over map, and for each is very similar. So when we pass in for each the callback function, it'll go through each element in the array, and it'll call that function that you pass in, passing the element as its argument. So anybody want to take a crack at what this would log to the console? The tricky thing here is that string, we don't see anything ever passing the argument string to the function, but it's just implied in the for each. When you pass in the function, it will pass each element of this array into the string as the string, and it just handles that for you. So this would just log everything, all of these elements to, yeah, exactly, everything here but to uppercase. The function that is passed into for each also takes an optional second argument, which is index. So anybody want to take a crack at this? Oh crap. Well, looks like you guys already saw it, but it basically does the same thing, but it passes the index too. So it not only gives you the string of the element, it not only gives you the element, it doesn't matter that it's a string, it could have been any data type, but it gives you the element, and it also gives you the index at which that element exists. So it would say, Brooklyn is at 0, Golden Gate is at 1, London is at 2. So basically the function that you can pass in to for each, there's a contract that says it not only takes this first, this argument is always going to be passed in by the function. So you always want to, in your function, at least have one parameter, right? Because otherwise, why are you even calling a for each on the array if you're not going to use the element that array consists of? So if you're not going to use that array or elements in that array, then there's no purpose of using a for each, because for each passes the function that you call it. It passes each element in that array. So if you want to do something on an array without having to create a for loop, you could do a for loop And honestly, for loop is a little more flexible, but for each just is a little shortcut, and it just allows you to call a function on each element in the array. Now, like, the difference between for each and map is that map returns an array with the result of calling the function on each element, whereas for each doesn't return anything. It just calls the function on each element in the array. So it doesn't return anything, which is the difference. So yeah, let's just go over that real quick, because I know that was fast and a lot of people might be confused, and it's completely fine to be confused. But let's just go over a little shortcoming of for each. So if we had an array, I could say array.forEach, and I'm going to pass it in a function. Log clothes, log clothing, and it takes clothing, it just logs it, right? And then I pass that into the for each. It's beautiful. It does its thing. It logs clothes and t-shirt, but I can't return it. Like, it doesn't return anything. So I can't say, let my clothes equals array.forEach log clothing, because this for each never returns anything. It just calls the function on this, and that's it. That's all it does. So I couldn't do something like that, because it would just be, my clothes would just be undefined. Like, it doesn't return anything. Like here, it's undefined. Like, it doesn't return anything or doesn't do anything. I mean, it does something, but it doesn't return anything. So let's say, I wanted to like capitalize all my clothes, right? So function capitalize clothing, and then it just returns, this one actually returns clothing dot to uppercase, right? And let's say I called that here. It's not like my for each is calling capitalize on close, but it's not returning that value anywhere. It's not saving that value anywhere. So like, it really does me no good. My close is still undefined. Undefined. It doesn't, because for each simply calls the function on this, so it calls capitalize on close, but it doesn't save that value of the function invocation anywhere. So if you want to return a new array, which is like in all likelihood what you would want, then you need to use a map, because map actually returns you a new array with all of the elements, the result of calling this function, this return value, it actually saves it into a new array and then it returns it for you. Whereas for each, it just calls the function. It doesn't save the value anywhere. So for each is only really for, if you wanted to maybe like mutate something, then it would kind of work, right? So if, I had let new array like this, and then I did something like array.forEach, and then let's say my capital actually like mutated something, like did like new array.push clothing, then even though this doesn't return anything and my close is still undefined, now like it did something, it caused a side effect, because my new array has the stuff, because calling this function didn't return anything, but it caused something to be mutated outside of it, so it actually, did something. So Leah asked, would you explain why a for loop is more flexible than a for each? That's a beautiful question. And yes, I will. Because for each, it is forced to run on each element in the array. You can't break early. So if this array is 1,000,000 elements, it has to go through each element. That's just implemented within the people that wrote JavaScript and such. So with a for loop, you could break early, which is nice. It's efficient. If I found this thing, break the loop. Whereas for each, you can't. So, there's always a trade-off. The more fancy a function looks, the more somebody else did that work, and so you're bound to how they did it. But it's nice because you don't have to type as much code, and your code looks clean. It's not very disheveled. It's nice and tidy looking, but you're giving up your freedom to somebody else's implementation, and you can't change that implementation. I can't change what for each does because somebody already created it for us. So it locks you in. So there's a trade-off there. For loops, that's it's like a basic building block. So it gives you a lot of flexibility. You can do within each iteration, you have everything you need to break early, do this, do that. And so it, while causing you to do more work, gives you more flexibility. Whereas these shortcuts, they tie you into however the implementation is done, and you have to just follow their their outline and their requirements. Any other questions on higher order functions? Basically at the end. So yeah, again, for each, there's you wouldn't ever really pass in a function that returns something to the for each, because where is that value going? It's going nowhere. You're just calling the function. So for each is good for stuff that you want to do side effects. You want to have side effects, you just want to call a function on an argument, and that'll log something, or that'll call another function, or that'll mutate something outside. But it's not useful to pass in a function that returns something into a for each, because that isn't going to get saved anywhere. You're not preserving that value anywhere. So for eaches are only good for functions that just do stuff, but they don't return anything. They can return stuff, but you just won't have that return value anywhere. You won't be able to do anything with that return value. All right, that pretty much. Are there any other questions? Can I do another example with callbacks? Sure thing. So let me try to do an example here. So let's see. Let's just do map. Let's just do map again. Map is confusing. So let's have a array of salaries, right? And you got some people, they're making different types of money. Having trouble. Is this 1,000,000? Okay. So let's do a redistribution scheme, or a tax scheme where we're just gonna tax everyone the same percent. This is probably not. For a simple example, we're just gonna tax everyone the same percent. So let's say you know, is it gross and net? I'm not sure. So like let's just say pre-tax. And then let's just say array of post-tax. Right? And how we would do this without writing any for loops is we would just say array of pre-tax dot map, and then we would need to let's just consider one example. The most basic building block is just one salary. So it's just like we create a function that says like compute post-tax, right? And then it just takes in one salary. We're not even thinking complicated with arrays. It just takes in a salary and then gives us the post-tax. And let's just say it's 30%, right? So then we just do times 0.3, or we just do times 0.7 and we just return that. So now we call that function, we pass this function in to map. And what map will do is it'll call this function, it'll create a new array, and it'll add for each element in the original array, it'll add the return value, this new value, into the new array, and it'll return you the new array. And this function is a callback function because it's being called at a later time. We're giving it to something and we're saying, hey, you map function, do what you will with this function. And so it says, okay. And there it is. Everyone's salaries after taxes.
So map goes and get all the elements in array of pre-tax, and then it calls the compute post-tax on all of them.
Yes.
And it computes the salary.
And then it passes that into a new array.
And then it passes that into the new array. Okay.
And this is called a callback.
Okay, this one is a callback. Okay.
It's a callback function. This function, the map function, is a higher order function because it takes a function as a parameter.
Takes a function, right? That's right.
So map is the higher order function, and compute post-tax is the callback, the function to be called back at a later time.
Okay.
Yeah.
I think I see the line now.
What was that?
I said I think I.
No, this takes some time, and let's just try and see what the array of pre-tax looks like, right? It's an object, it has a map function, that's a function, and it takes a callback function. That's this. Map takes a callback function. It also has the actual values is an array of this, right? And then it has a callback function, and then it says let new array equals a brand new array, and it'll say for let I this for loop's killing me. This dot value I, oh wait, what am I doing? This dot values dot length I plus plus new array dot push callback func this dot values I, right? And then we're returning the new array. This is basically what map looks like. It's a higher order function because it takes a function as a parameter, and then it creates a new array, and then it pushes into the new array. It iterates over all its values, and then it calls the callback. It calls this function, and it gives it the element as the parameter, and then it returns the new array. So Leah asked, do callbacks have a specific scope? Yes, the callback is just this function, so it has the scope of this function. It's just renamed as callback function, or it could be named whatever you want, but we're just aliasing the original function that we're passing in to be this, and then we're just calling it. So that function, that question is, I guess it can be really complex, because if you pass, so I guess it's different, because whatever scope the function had when it was declared, it's now in a different scope technically. So it's in this scope right here of this object. And so you're right, the scope does change, but I don't want to get too in the weeds of that yet, because that's pretty an advanced concept. For now, I would just think like functions are flexible. You can pass them in to different functions and call them inside that function, and you can some things are implied, like nothing is actually directly passing this value into this function, but because of the way that this function is implemented under the hood, it is the one that's passing the value in to your function for you. But that was a good question. Technically, I was wrong. I take back my statement. The callback function's scope changes because now it's executing in this function, in this scope, which is a different scope than had it been executed in this outer scope. This is a different scope than this. So it's different scope, you're right. And that is what can cause confusion and interesting behavior with callback functions. But that we won't get into yet. Any other questions? Do we have more workshop after this? And when we'll be taking our assessments? Nice, so let's go higher level. So we have a lecture Monday, higher order functions, 2. And then we have 2 more lectures on recursion, which is like, everyone likes to ask a recursion question on an interview. And then we take the practice assessment on the last day, which is the day after recursion 2. And then that one doesn't count for anything. Nobody looks at it, nobody analyzes it. It's just for you to be familiarized with the testing environment. And then you'll have as much time as you need to take practice assessment 2, which will be looked at. But if you fail it, like, you could just take it, the normal one. This one is something that you could use to be your actual assessment, but if you don't do well, then you could just take the normal assessment, like as if a normal student that didn't take bootcamp prep. Any other questions? And yeah, I think it doesn't expire, Grace. I believe not. All right. So I'll be doing the review for today's workshop on Monday. So again, if you guys have questions, please use the help desk right here and ask some of our fellows to hop into the room with you. I will be AFK, away from the keyboard, for about half an hour to an hour. So yeah, please reach out to any fellows, but I'll be also monitoring after that if you guys have any specific questions. But we'll go over the workshop on Monday, and I'll release the solutions as well after the workshop. So yeah, let me put you guys into some breakout rooms. Feel free to take a break.